Hey guys, Mr. Riss here to help you out with the second part of the 5.4 notes in Algebra 2. So what we're going to be doing today is solving equations that have two radicals. So here's an expression example, and I'll solve out for you what we need to do. And I'm just trying to explain what we're going to do, and then we'll do one together. So if we look to solving an expression that has two radicals, we need to isolate one of the radicals first. And it doesn't matter really which one we isolate first. I try to look for the easier um, the one that's, I'll get the easier one on the other side, but we got this x plus 9 here. We're going to add the radical 2x over to the other side. Once we isolate a radical, we're going to square it to square both sides. One thing but we're going to have to watch out for, when we square this radical 2x plus 3, we're going to have to write it out twice and FOIL it. Now, what will end up happening is we will still have a radical left over when we square this one here. It'll be right in the middle of the term. What we need to do is kind of repeat the process. We need to isolate that radical, and then once we get it isolated, we need to square both sides. What will end up happening, typically we'll have some quadratics, and sometimes we'll have some extremely large numbers, but we'll move things around, solve it, and we'll end up getting two answers. Now, just like before, when we get two answers, we need to plug them both back into the original problem at the very beginning to see if we get the right values. Sometimes we can get ones that work. Sometimes we don't, and we get what's known as extraneous solutions. We can also kind of figure out some of these answers by graphing them. But let's go through and solving to make sure we get this. So these are going to take a lot of space and a lot of room. And so I'm going to go ahead and take these problems in our notes, and I'm going to open up a whiteboard to do this problem here. Let me write them down real quick. Do that. Radical x plus 4 minus radical 3x equals negative 2. And radical 15 minus x minus radical 6x equals negative 3. All right, and feel free to use any, of the space here, but I'm going to use a whiteboard. There we go. Okay, so let's give this a try. All right, we got radical x plus 4 minus radical 3x equals negative 2. All right, so we need to isolate one of the radicals. We'll isolate this one here. So we'll add the radical 3x over to the other side. We get x plus 4 is equal to radical 3x minus 2. All right, the next thing we would do is to square both sides. And so this becomes x plus 4. And now this side over here, we need to write out radical 3x minus 2 twice and FOIL it out. All right, so we got x plus 4 is equal to, all right, radical 3x times radical 3x. It's technically radical 9x squared, but we know that's just going to cancel out the radicals. We get 3x. All right, radical 3x times negative 2 is negative 2 radical 3x. Then next in the middle here, negative 2 times radical 3x is also negative 2 radical 3x. And then negative 2 times negative 2 is positive 4. So if we combine like terms here, we get x plus 4 is equal to 3x. And then we can combine those middle terms there. We would get a minus 4 radical 3x. We just add the numbers in front. We don't change the radical. And then plus 4. Okay, so the next part of this problem is we need to have this radical isolated. So we'll move this 3x over and we'll move that 4 over. So if we had x but we took away 3x, we have negative 2x. And then if we had 4 and we subtracted 4, well, we have 0. Nothing's left over. All right, and that's going to equal negative 4 radical 3x. It's probably not a good idea to normally have negatives here, but our next step to get rid of this radical is to square both sides. When we square a negative 2, it becomes 4, and we square x, it becomes x squared. Now here, when we square this, we do square the negative 4, which becomes 16, and then radical 3x squared just becomes 3x. We don't have to write this out twice and FOIL it because it's not a minus sign or plus sign in between. It's just a regular term being squared. All right, so let's try to simplify this here. I'll put it over here. We have 4x squared is equal to, all right, 16 times 3, that's 48x. All right, so now what we got is a quadratic problem because we have an x squared. So we need to minus the 48x over. set it equal to 0. We need to make the equation equal 0. Now this problem here is just a two-factor or two-equation GCF factoring. We can divide both of them by 4 and factor out an x. Didn't mean to really put that minus sign there. So what ends up happening when we divide both of these by 4x squared becomes x. Let's see, and then minus 48 divided by 4 is 12, and we got rid of the x. All right, so now what we need to do is take both of these parts and set them equal to 0 and solve those. All right, so 0 divided by 4, that means x equals 0. Add 12 over to 0, 0 plus 12 is 12. So we got two answers. We got 0 and 12. The last thing we need to do is plug them back into the original problem to see if they both work. So let's try 0 first. Little too big there. All right, does the square root of 0 plus 4 minus the square root of 3 times 0 equal -2? All right, so let's see. 0 plus 4, this is the square root of 4 minus the square root of 0. Does that equal -2? Does 2 minus 0 equal -2? No, it does not, so 0 does not work. All right, so we'll try again with 12. Does the square root of 12 plus 4 minus the square root of 3 times 12 equal -2? Does the square root of 16 minus the square root of 36 equal -2? Does 4 minus 6 equal -2? Yes, it does. So 12 works. So 12 is the solution. 0 is the extraneous solution. All right, let's try this one more time with the other problem here. Radical 15 minus x is minus radical 6x is equal to -3. So what we need to do is isolate the radical, add the radical 6x over. We get radical 15 minus x is equal to radical 6x minus 3. So we need to square to isolate, or since this radical is isolated, we need to square that. We get a 15 minus x, and over here we'll write this out twice. Radical 6x minus 3 times radical 6x minus 3. Did you guys know it? Anytime you can pause the video, try it on your own, and then watch it to see if you did this right. All right, so 15 minus x is equal to, we'll multiply radical 6x times radical 6x. Just breaks down to regular 6x, no more radical. Radical 6x times -3 is -3 radical 6x. Moving on in the middle here, -3 times radical 6x is also -3 radical 6x. They will always be the same too. And then -3 times -3 is a positive 9. All right, so let's combine those together. We get 15 minus x is equal to 6x minus 6 radical 6x plus 9. Let's isolate this radical by itself by minusing the 6x over and then minusing the 9 over. So we would get, let's see, if we take away the 15, or 15 minus 9, that is 6, and then minus, we had 1 here, and we're going to subtract 6 minus 7x. And that is equal to -6 radical 6x. Okay. Next thing we need to do is to square both sides to get rid of this radical. And so I'm going to write out 6 minus 7x twice. Because this is a polynomial, it has a minus sign, we write it out twice when we square it. Now this is just one term. There's not a minus sign in the middle or a plus sign in the middle. So we can just square the -6, which is positive 36. 6x. Okay, so let's FOIL this out. What tarnation do we have here? All right, 6 times 6 is 36. 6 times -7x is -42x. 7x times, okay, that's also -42x. Remember, they're always the same in the middle. -7x times -7x is a positive 49x squared. And that is equal to 36 times 6. I'm going to have to take out a calculator. I think that's 216. Yeah, it's 216. Okay, so we have a quadratic. That means we need to make the equation equal to 0. So we're going to minus that over and write down what we got. So we have, I'm going to put this in descending orders. We got 49x squared. And then we would have, let's see, minus, if we had -42 and we minus 42 and then minus 216, That is an even negative 300x and then plus 36 equals 0. So we just move some things around. Now we need to factor this. All right, this is where it gets a little tricky. Now, if we don't like to factor, you can always do, okay, x equals negative b plus or minus the square root of b squared minus 4ac. Oh, I lost the whiteboard. All right, let me double check that if you guys can see this. Uh-oh. I hope I've been recording this. We could go through all the quadratic formula, or we can go through and see, okay, what two numbers multiply together to give us, all right, what's 49 times 36? 1764, good year. And then add together to get negative 300. All right, it does work out. Let's see. Negatives are just gonna start guessing, checking. So what about 64? No. Oh, we got to get 300. Oh man, I don't know. 112 or something? No. 1764 divided by 24. No. It's 12 and 147. So it needs to be smaller than that. All right. 1764 divided by 8. No. No, not by 3. What about 6? All right, there we go. So after some guessing and checking, it is negative 6 and negative 294. That's what you guys all knew, right? Negative 6 and negative 294. No. All right, so that means we would set this up as x minus 6 and x minus 294. But there is a number in front, so we divide by that number in front by 49. Now that number does not simplify, so we would slide it over. So this would be 49 x minus 6 times, all right, does 294 simplify? Yes, it does. It is 6. All right, so we're going to set both of these equal to 0. Does 49x minus 6 equal 0, and then x minus 6 equals 0? So we have two answers. One of the answers here is that 6, and the other answer is 6 over 49. We'd add the 6 over and divide by 49. All right, so we need to double check that both of these work. I'm going to first check 6 because that's way easier and less scary than to plug the other one in. So checking 6, does the square root of 15 minus 6 minus radical 6 times 6 equal negative 3? So does the square root of 9 minus the square root of 36 equal negative 3? Does 3 minus 6 equal negative 3? Yes, that does work. All right, the next question, does 6 over 49? Whew. Okay, can I get some room here? All right, I'm going to take this problem here and try to get a little, that's not going to work. Let's try that again. Oh, wow. That doesn't work either. This is like, all right, trying to get used to my pen here. There we go. Just want to make that a little smaller. All right, let's plug in 6 over 49. Now you probably guess like, oh, that's ugly. Probably won't work, but you know what? I'm gonna check anyways. Minus 6 over 49 minus square root of 6 times 6 over 49. Does that equal negative 3? All right, I got to take a calculator out. What's 15 minus 6 divided by 49? And that gives me a word decimal. I'm going to turn that into a fraction on my calculator. And I get 729 over 49. And then minus, this one I know is 36 over 49. All right, so next, what's the square root of 729? I think that comes out nice. That's 27. So this is 27 over 7 minus square root of 36 is 6 over 7. Does that equal negative 3? So we could subtract those together. That'd be, does 21 over 7 equal negative 3? No, that's a regular 3 over 3. Or 3 does not equal negative 3. So that doesn't work out. It's a word fraction. Probably wouldn't have worked out anyways. All right, so we get a final answer of 6. So don't be afraid of these problems, guys. You can see there's several steps, and that's what I'm going to be judging along the way. Could you isolate the first radical correctly? All right, then after that, did you isolate the next radical? Then after that, did you solve the quadratic? Then after that, did you check for extraneous solutions? So take your time, and if you break it up into 4 chunks, it actually doesn't make the problem too bad. All right, I will see you guys next time for the next section, but good luck on this.